Okay, this is Basic Rules of Exponent Part 2. Now as we go over these rules, let's remember a very important fact. You can only use these rules with bases that are the same. Now look at 5 to the 4th times 5 to the 3rd. We have 5 and 5. We have like bases. Those bases are the same. So we can use these rules with that kind of operation. But to the right here, the 5 and the 3 are your bases. They are not the same. So none of these rules will apply to this. So yes, when the bases are the same, no, when they are not. So now that we have that established, let's go on to the first rule. And the first rule we're going to be looking at is the power of a product. Okay, so let's take our first example. We've established we have to have like bases. So what if we have 3 squared times 3 to the 3rd? What is that going to equal? Well, let's look. We know that 3 squared is 3 times 3 times, we know that 3 cubed is 3 times 3 times 3. So how many? We have 3 to the what here? 1, 2, 3, 4, 5. Well, let's look at it this way. Is that not just the same as 3 squared times 3 cubed is the same as adding the 2 and the 3 gives us 3 to the 5th power. That is called the product of a power. I'm sorry, it is the power of a product. This rule, when we are multiplying bases, we add the exponents. So the power of a product, add your exponents. In this case, we get 3 to the 5th. The rule is the power of a product. Now let's look at another example using the power of a product. What if we have 3 squared times 3 to the 7th times 3 to the negative 5th? What does that equal? Well, we're going to follow the same rule that we just did. We're going to add those exponents. So we have 3 to the 2 plus the 7 minus 5 will give us 3 to the 2 plus 7 is 9 minus 5 is 4. We have 3 to the 4th. Let's take another example. 3 cubed times 3 to the 4th times 3 squared equals, let's just add them up. 3 plus 4 plus 2 is 9. So we come back, we have 3 to the 9th. Okay, let's look at 4 cubed times 3 to the 4th. What do we get here? Well, if you remember what we said, our bases have to be the same. Is 4 the same as 3? No. So here we cannot combine them. Cannot combine. Now let's look at one last example at the power of a product. Let's take m squared times m to the fourth times n cubed times n squared. Well, here we have like bases of m and like bases of n. So we can combine the bases for m and get m to the sixth times, and combine the bases of the n, we get 3 n's and 2 n to the fifth. And this is as far as we can take it. You may sometimes see this written m to the sixth, n to the fifth, because we know when we have variables right up against each other, it means to multiply. So now we've gone through the power of a product. Let's go on now to the next rule, which is, we'll learn the quotient rule. And let's say we have 4 to the 8th divided by 4 to the 5th. Well, you remember in the power of a product, when we were multiplying, we added the exponents. So because we're dividing here, what do you think we're going to do? That's right, we're going to subtract. We can also set this up as 4 to the 8th over 4 to the 5th. And take our exponents. What's 8 minus 5? 3. This will become 4 to the third power. Or you can do it just like this. At the first one here, what's 8 minus 5? We get 4 to the third in either case. What if we just have variables? W to the m divided by w to the n. We have like bases, so we can combine them. This is going to become just simply w to the m minus n. Let's keep going. One last example on the quotient rule. 12 to the negative 6th divided by 12 to the negative third. Well, let's set it up this way. 12 to the negative 6 divided by 12 to the negative 3. We're going to have negative 6 minus a negative 3. And this will apply to whether we're talking about A or B. We could set it up either way. But you know that subtracting is the same as adding the opposite. So negative 6 minus negative 3 is the same thing as a negative 6 plus 3. Which, what do we get? You're right, a negative 3. This will become 12 to the negative third. We have now gone through the quotient rule. The next rule is the product of a power. This simply means, what if we have a number 5 squared to the third? Well, let's look at it this way. 5 squared, you know, is 5 times 5. So how many of these 5 times 5 are we going to have? 3. So how many do we have? 1, 2, 3, 4, 5, 6. So 5 squared to the third is 5 to the sixth. But notice, we can do it more simply by going 5 squared times 3, which will equal 5 to the 6th. Notice how this is different than the power of a product. Here we want the product, the multiplication of a power. So we're multiplying the powers. What if we had w to the m times w to the n? You're right, we're just going to have our same base, w to the mn. And remember, m and n right together means multiply. So this is the product of a power rule. The next two rules are very simple ones, just to remember: the 0 rule. And in this case, your base cannot be 0. So x to the 0 is always going to equal 1. 3 to the 0 is 1. Your rule is simply any number to the 0 power equals 1. So I don't care whether it's 1 to the 0 power, 5 to the 0 power, or 856,000 to the 0 power. They all equal 1. And the next one here is the power of 1. Any number, and I'm going to use the number sign, any number to the power of 1 equals that number. So 7 to the first power is 7. Because look, you have 1, 7. 4 to the first power is 4. M to the first power is m. The last one is negative exponents. Let's say we end up with 4 to the negative 3. Many times you're going to be told that you have to express your answer as a positive exponent. Well, how are we going to do that here? Because this is a negative exponent. It's very simple. Remember this rule. The reciprocal is a positive exponent. So coming back to 4 to the negative third, that is the same thing as, okay, what's the reciprocal of 4? 1/4, and it makes it a positive exponent. So we get 1 over 4 cubed, which if we work this out, we know 4 times 4 times 4, which is 1/64. And that, students, is our last rule of exponents that we are going to be studying this year.